Actually, I lied. We're not going to start with E because E is a different kind of problem. So I'm going to skip. I'm going to skip around. We'll come back and get them all. I'm going down to G. Letter G. Now, just to refresh your memories, because it's been a few days, we have a property of logarithms that says if you have a number raised to the log base that same number, the answer is just the exponent. When these two oh, wait a minute, that's not the property. That's the one we're going to use in a minute, but the one we're using now is this one. When you have log base b of b to the x, when these two numbers match, that is going to be your answer. So I'm going to cover up this 4 for a moment, and I'm going to look at what I have right here. Can anybody tell me what the answer to that part of the problem is? Notice these match. So the answer is the exponent right here, but I don't see an exponent. What is the understood exponent in that spot? 1. So the answer to this is 1. You don't need a calculator. You don't need to show any work. The answer to this is 1. But we were multiplying the problem by 4, so the final answer of the problem is 4. All right, I. Remember, I'm skipping around. We'll come back and get all of them. Don't worry. Log base 8 of 1. Anybody want to take a stab at that? It's kind of unfair because we haven't talked about it. The log of 1 is always 0. And here is why. Okay, let me back up. You got to remember the log of 1, no matter what the base is, if there's a 1 there, the answer is going to be 0. But the logic behind that is that 1 can be written as 8 to the 0th, right? 8 to the 0th is 1. Well, now these match, so the answer has to be 0. And that will be the case no matter what the base is. If I change this to a 7, it's still 0. If I change it to a 17, it's still 0. The log of 1 is always going to be 0. All right, what about J? It's kind of like a puzzle, guys. You need this number to be a 7. You need this to say the log base 7 of 7 to some power. Well,
is the answer 1/2?
It is 1/2. Beautiful. Because we know that a radical means a fractional exponent. And since that's a square root, it has to be a 2 in the denominator. So this problem is the log base 7 of 7 to the 1/2. So yep, the answer is 1/2. Beautiful. How about this one? I can't.
2.
Yeah, remember the base on LOG, and I think I told you this, but if I didn't, you need to know that LOG is the log base 10. If you have just a plain LOG and there's no base, it's 10. It's understood to be 10. Now these two numbers need to match. So you got to write 100 as 10 to a power. Well, he already did that. He said the answer's 2. And he's right. The log base 10 of 10 squared. Log base 10 of 100. Good, good, good. How about this one? Anybody want to take a wild guess on this one? What the answer would be? This is M. Letter M.
One-third.
Yeah. Who said that?
Trey.
Of course. Thank you, Trey. Here's the deal, kids. You need these two numbers to match. So you need to be 6s. So what power is a cube root? Well, it's a radical, so it's a fraction. It's a cube root, so it's 1/3. That's how we got 1/3. Beautiful, beautiful, beautiful. Next, we have an ln. Now remember, ln is log base e. So you need this right here to be written as e to a power, because you need this to match the base so that you can cancel them out. What power is 1/e cubed? Now, it's 1/, that means it's negative. -3. If you take e to the -3rd, that means 1/e cubed. Your life in logarithm land is going to be so much easier if you remember all the exponent rules. Negatives flip you over. E becomes 1/e. O. Kind of the same thing. We need this to be a 4 to a power. So 1/16 is 4 to what power? Can you figure that out? 1/16, 4 to a power.
-2.
Yep. I don't know if you guys are zoned out, or if you're not getting it, or if you're getting it. I don't know. You need to talk to me about this. Because I'm not going to keep explaining every problem if I don't need to, and I don't know what's going on there. So 4 to the -2nd means 1/4 squared, which is 1/16. So these match, so the answer is -2. Because 1/16 is 4 to the -2nd. All right, Q. Again, I'm going to come back. Don't worry, we'll get them all. But I'm trying to do all the like problems first. So we got log of 1,000. Okay. What's the base here? 10. Yep. So I need to write 1,000. 1,000 has to be written as 10 to a power. Well, what power of 10 is 1,000? Ten to the what? Yep, 3rd. So the answer to the problem is 3. The magic in these problems is making sure that you have rewritten your number as a power of the base. Then you can just cancel them out, and the answer is the exponent. We looked at one like this earlier. This is R. It's got that number out in front. So let's hold off on that number, and let's figure out what this is. Can anybody besides Trey, and I love you, Trey, anybody besides Trey tell me what the answer to this is?
Is it 3 squared?
Yeah, well, so the answer is 2, because it's the log base 3 of 3 squared. 3 squared is 9. So this part of the problem just equals 2. But we had a multiplier out in front, so the final answer of the problem is 4. S is exactly the same thing. It has this coefficient, so for a moment I'm going to wait on that, and I'm going to figure out this part right here. What's that part?
cubed.
Yeah. 8 is 2 cubed. So the answer is 3 to that part. But that 3 is being times by 3. So the answer is, the final answer is 9. Aiden Muska, you okay? All right. Now, I'm going to go back and pick up all of the other problems because they're a different style. The other problems have a logarithm in the exponent. So when we have a logarithm in the exponent, so it's something to the logarithm power, which is what's happening in letter E, for example. When the base, the number, and the base of the logarithm, when these two match, the answer is just that other number. So these are actually easy. There's really no work involved with these. What's 6 to the log base 6 of 10? 10. That's it. Yeah. There's no work. There's nothing. So what's the answer to F?
2.
2. Yeah. H is exactly the same thing. Please do not be concerned or confused by H. Remember that ln is log base E. So what's the answer? 6. In some of our other problems, we've talked about when you have an ln and an e back to back, they cancel. Same thing here. When you have an e and an ln touching each other, the answer will be the other number every time. This is y, but that's going to happen every single time. All right, where's the next one? How about P, letter P? Don't be confused. What's the base on that log?
10.
10. So you have 10 to the log base 10 of 7. So the answer to P is 7. And then T, very last problem. What's the answer to it?
4.
Yeah, it's 4. Anybody have a question about any of those problems? We all good? All right, then we're moving on to part 2, or number 2, which is super exciting. We are going to solve some basic logarithmic equations. So you did this last year, but we're going to go through it again, just in case maybe you forgot. I'll give you a chance to show off. Anybody remember how to do this? Well, you will when I show you. First of all, I want you to remember that the base on log is 10. So I'm going to go ahead and fill in that 10. And then I'm going to do what we call loop-de-loo. I'm going to start with the 10. Start with your base and say 10 to the 3rd power equals x. That motion, watch my hand, 10 to the 3rd equals x. That's why we call it loop-de-loo. We like make a loop there. So 10 to the 3rd equals x. So the answer to that problem is 1,000. 10 to the 3rd. It's that easy. When you have one logarithm, it's that easy. So this is going to be the same thing. Put a 10 in there because you need your base to get started. That's where you start. 10 to the negative 1st equals x. 10 to the negative 1st equals x. What's 10 to the negative first?
130.
Yeah.
Okay.
Yep. So we got to simplify, guys. We got to go ahead and simplify. So the answer would be 1/10. This one's exactly the same. 10 to the negative second equals x. Everybody watching my hand? 10 to the negative second equals x. If you do that motion, you will always get the right answer. What's 10 to the negative second?
1 over 100.
Exactly. Don't question yourself. You got it. Right on. Perfect. Now, the next couple are the same thing, but they are LNs. Please don't forget that LNs are just another kind of logarithm. So this is log base e of x equals 4. Ln is log base e. So what's the answer going to be?
E to the 4th equals x.
Yep. And remember, e is a constant, the base of the natural logarithms, Euler's constant. So we treat it just like pi. This represents 2.718, but we just leave it as e. Everybody knows what it means. So e to the 4th, that's it. What's the answer to the next one?
E to the 6th.
Yep. E to the 6th equals x. That's exactly right. Ln means log base e. Now, this one's a little bit of a curveball here. You cannot loop-de-loo. You cannot solve a logarithmic equation because different people use different words. We don't always say loop-de-loo. That's Mr. Mike Miller's word, our math teacher. But that's how you solve a logarithmic equation. This to this equals this, period. That's how you do it. You cannot do that if there's a number out in front. So this is an equation. This has an equals sign. What might I do if I'm not allowed to have that 3 out in front? I'm just going to divide both sides by 3. Of course I am. It's an equation. Of course I'm going to divide by 3. Now I don't have that coefficient anymore. I just have log x equals 1. I know my base is 10. So 10 to the 1st equals x. So x equals 10 is the answer to the question. G, same thing. Exactly the same thing. I know it's a natural logarithm instead of a common logarithm, but procedurally we do it exactly the same. So I'm going to divide by -2, divide both sides by -2. Then I'm going to remember my base is e, so I have e to the -2nd equals x when I loop-de-loo. Negative flips, so it's 1 over e squared. Anybody have a question about that? All right, log x equals 1/2, log x equals 1/3, ln x equals 1/4. Remembering that the base here is 10, translating this into an exponent form would be 10 to the 1/2 equals x. Now that is perfectly okay, but can anybody think of another way I could write that answer if I wanted to? If I wanted to, is there another way I can write that answer?
X is equal to the square root of 10.
Yep, I could write that as the square root of 10. 10 to the 1/2 is the square root of 10. There is nothing wrong with fractional exponents. So 10 to the 1/2 is fine. You could also say the square root of 10. So what's going to happen here? This one's going to be 10 to the 1/3, right? 10 to the 1/3. What's another way of writing 10 to the 1/3? The cube root of 10. This one's going to be e to the 1/4. And another way of writing that would be the 4th root of e. Again, you can leave them with fractional exponents. There's absolutely nothing wrong with that. Fractional exponents are radicals. So anytime you have a fractional exponent, you know you have a radical. Now, you just worked through, what, about 10, or I worked through 10 very basic logarithmic equations. You feel like you got a grip on that? Yeah, it's pretty easy. The problem is, out there in math land, we don't usually have just one logarithm, and that's the key. If I'm going to loop-de-loo this, I got to have just one logarithm. Many times, usually, in fact, you have more than one logarithm. So, what we're going to talk about next, get as far as we can here in 3.4, what we're going to talk about is how we put logarithms together so that we only have one. There are 3 things I want you to write down, either in the margin of your notes or somewhere where you won't lose it. Don't put it on a scrap of paper. I need this somewhere where you can find it. These are the rules how we combine logarithms into one expression. So if we had the log base b, and this works for any base, the log base b of m plus the log base b of n. So in other words, if you have 2 logarithms being added together, they will combine into a product. So the log of m plus the log of n combines into one logarithm by multiplying those 2 numbers. If you have a problem where the logarithms are being subtracted, so 2 logarithms, they're being subtracted. Anybody want to take a wild guess how that combines?
You divide.
Exactly, m over n. First over second, yep, exactly, very good. And then the third combining rule says if you have a situation with a coefficient out in front, that coefficient actually represents an exponent. And we've talked about that, you and I have, in our various problems. We've used that rule. If you have a coefficient, the first thing you need to do is make it a power, and then you can start doing other combining things. So these are the rules we're going to use to do these 6 problems here in 3.4, number 1. Notice that the directions say, write as a single logarithm. So in problem A, you have 2 logarithms. You need to combine them into one. Well, notice they're being subtracted. The 2 logarithms are being subtracted. So what's going to go in the parentheses?
X over y.
Yeah. Isn't that easy? That's exactly what goes there. Good job. Now B, and they go sideways this time, B says 2 log x plus log y. You cannot combine these until you deal with that 2. That 2 has to be taken care of. So I'm erasing my rules right now, but what did we say we were going to do with these coefficients out in front of logarithms? Where do they go? Exponents. So we're going to have the log of x squared plus the log of y. Now I can put them together. These 2 logarithms have to go into 1. You cannot solve a logarithmic equation that has more than 1 log on each side. These have to be put together. How are they going to go together? What's going to go in here?
X squared multiplied by y.
Thank you. X squared y. Very good. Because the rule that I erased says that when logarithms are added, the numbers are multiplied. Don't freak out. Same kind of problem. These numbers out in front represent exponents. Once I get those exponents moved, I can combine these into 1 logarithm. Please don't drop the logarithms. That is not allowed. I'm combining the 2 into 1, so I still have a logarithm. What's going to go inside the parentheses? Well, I can do it this way. Multiply them together. Or, if I prefer the radical version, this would be the cube root of ZW squared. If I want to write it as a radical, this would be the exponent form. Both of these are cube roots. It's a cube root of Z and the cube root of W squared. So I could write it as one big radical. If I chose to, this is fine. The exponents are fine. Oh, now the next one, D, has numbers, not letters. But we're going to do it exactly the same way. So we're going to start by popping these exponents up there. So I have 16 to the 1/2. And I have 8 to the 2/3. Whoops, 2/3. Messing that up all the way around. Log 8 to the 2/3. There we go. So the 1/2 comes up here on the 16, and the 2/3 comes up here on the 8. Now, it's not okay to leave the fractional exponents. These simplify, and they need to be simplified. What's 16 to the 1/2?
4.
Yep. So this is the square root of 16, so that's 4. Now, 8 to the 2/3 is probably not on the tip of your tongue. It might be. But remember, a fractional exponent means a radical. Denominator gives you the root, numerator gives you the power. So what's the cube root of 8?
2.
Squared is 4. Oh my gosh. Oh my gosh. We have the log of 4 minus the log of 4. They just cancel each other out, and we have 0. They're exactly the same thing. These are equal to each other. Now, this is actually a good illustration of something we talked about before. If we used our property to combine these, wouldn't we divide, since it's a subtraction problem? And we'd have the log of 1 And what did I tell you that the log of 1 always equals? 0. Yep. So it all works out. I love it when all the pieces fit together. All right, let's try this one. Andrew? Are you playing video games, Andrew?
No,
You're paying attention?
trying to.
Okay, well remember, if I can't see you, I'm to mark you absent. Don't put me in that position, please. All right, here we go. First thing I gotta take care of are the exponents. So it's gonna be ln2 cubed plus ln 36 to the 1/2. Tyler Kunkel, what's 2 cubed?
Can you repeat that?
Yeah. You wanna wake up and pay attention here?
Yeah, sorry.
Okay. 2 cubed. What's 2 cubed?
8.
Yeah. And what is 36 to the 1/2? Tyler?
6.
Or, well, yeah, somebody else said it's 6. And it's 6 because a fractional exponent means a radical, so this is the square root of 36, which is 6. Now I'm going to put those together. What's going to go in the parentheses when I combine ln8 and ln6?
48.
Yeah, don't question, you're right. It's a plus problem, an add problem, so we are simply going to put them together as a multiplication. Beautifully done. One more. Here we go. First thing we're going to do is take care of our exponents. So I'm going to have the log of x to the 4th, y to the 4th, minus the log of x cubed. Now, look at the problem. Does everybody understand how I got this as my first step? Now I'm going to put them together then. And what's going to go inside of here?
X to 4, y to 4th over x to 3rd.
That's exactly right. This time, I can actually reduce my fraction. So I need to do that. I always need to do basic reducing. So my final answer is going to be the log of, looks like just 1x, y to the 4th. If I cancel my x cubed into my x to the 4th,